Alrighty, hi Bruins, and welcome to the first Clayton Science video post of 2019. We're going to get started today by reading the reading assignment called Fossil Dating. Fossil dating. Earth is a very old place. According to recent evidence, it is around 4.6 billion years old. Geologists call this vast amount of time geologic time. We know about past life by looking at remnants, marks, or traces of life forms trapped in rock. Rocks hold the key to much of what we know about Earth's history and the evolution of life on this planet. Fossils are evidence of ancient life. Most fossils are body fossils or trace fossils. Body fossils are rocks made from parts of the organism. The hard parts, such as shells, bones, and teeth, are most likely to become fossils. Trace fossils preserve evidence of activities. These rocks most often show tracks, tail drag marks, burrows, impressions, and droppings. Trace fossils like these trilobites are impressions left in mud that harden to rock. Millions of years later, these impressions provide clues about how and where the animals lived. Relative dating. Most fossils are in sedimentary rock. Sedimentary rock forms over thousands, sometimes millions of years. First, particles of gravel, sand, and mud settle on the bottoms of rivers, lakes, and the ocean. Little by little, those sediments pile up. Sediments also form in the desert. There, particles of dry sand drift and build up. Sediments sometimes cover dead organisms. The soft parts of organisms usually decay or are eaten, but the hard parts of organisms can remain. As sediments build up, the remains are buried deeper and deeper. The sediments become compressed and form rock around what remains of the organism. Here's our first think question. You're going to put this onto page 127. Fossils are relatively rare. Why don't we find more? In the 1600s, Nicholas Steno, 1638 to 1686, figured out how sedimentary rocks form. The Danish scientist said that lower layers of rock were laid down first. They are usually older than the layers of rock above. This rule is the principle of superposition. This principle allows paleontologists to compare fossil ages. A fossil in a lower layer of sedimentary rock is most likely older than a fossil found above it. This useful rule tells us the relative age of fossils, but it does not tell us how old a fossil or rock is. To do that, we look at the atoms in the rock. So here is a picture that shows a little bit about relative dating, where we have the law of superposition, and it says superposition right here. So the lower layers are older, the higher layers are younger. Absolute dating. All matter is made of particles called atoms. Each atom is an element such as carbon, potassium, uranium, or oxygen. Atoms are made of even smaller particles. In any one element, the number of smaller particles can vary. For example, carbon comes in 3 forms: carbon-12, carbon-13, and carbon-14. Each form has a different number of particles and is called an isotope. A radioactive isotope loses small particles at a fairly constant rate. Gradually, it changes into a different isotope. If it loses enough particles, it can change into a different element. This is radioactive decay. Different radioactive isotopes decay at different rates, depending on the isotope. It can take minutes to millions of years for half of the radioactive isotope in a sample to decay. This time is the half-life of the isotope. Isotopes with a long half-life are used to date rocks. For example, the half-life of uranium-235 is 704 million years. It takes 704 million years for half of a sample of uranium-235 to turn into another element, lead. By measuring the ratio of uranium to lead in a rock sample, geologists can calculate when the rock formed. For example, if a rock is 50% uranium-235 and 50% lead, we know it is 704 million years old. Once you know the age of the rock, you know the age of the fossils in that rock. And here is a diagram that talks about radioactive decay. So here's the uranium isotopes. Radioactive parent isotope atoms in a rock sample, uranium-235. Some of those decay and turn into lead, and that's what the PB stands for. Using carbon-14. Carbon-14 has a half-life of 5,730 years. Paleontologists use this isotope to measure the age of fossils of organisms that lived in the last 50,000 years or so. Carbon-14 occurs in the upper atmosphere. All living organisms take in carbon-14. When an organism dies, it no longer takes in carbon-14. Instead, the carbon-14 in the remains decays to form another isotope of carbon, carbon-12. By measuring the amount of carbon-14 and carbon-12 in a sample of bone, hair, or wood in a fossil organism, scientists can determine how long ago it died. So here's another think question, again on page 127. Why isn't carbon-14 used to date rock that is millions of years old? So I'm just going to pan out here a little bit to show you this geologic time scale. We're going to look at this in class as well. Okay, and then we're going to continue on with our reading. Zoom in just a little bit more, bear with me. Okay, geologic time scale. Geologists and paleontologists use relative and absolute dating to estimate the ages of sedimentary rock and fossils. They have used the fossil record to develop a model called the geologic time scale. This model describes what we know about how old something is or when something happened during the history of life on Earth. Study the geologic time scale presented on the left. It shows when different kinds of organisms first appeared. Eras are broad spans based on typical life forms at that time. Zoic refers to animal life. Okay. Paleozoic means ancient animal life. The Paleozoic area included a group of extinct marine arthropods called trilobites. This era included corals, brachiopods, and early marine organisms with two hard shells or valves, early fish, and early amphibians. Plants of this era included early conifers and ferns. Mesozoic means middle animal life. It is sometimes called the age of the dinosaurs. Cenozoic means recent animal life. It is sometimes called the age of mammals because so many new kinds of mammals appeared during this era. Each era is divided up into periods that reflect the fossil record. Oops, I am down a little bit more. The geologic time scale is constantly being tested and revised. Geologists improve the model with new information from fossils and data. Okay, there are a large amount of think questions here. We're actually going to do these together in class. So the only think questions I want you to work on are this one. Why isn't carbon-14 used to date rock that's millions of years old? And this one. Fossils are relatively rare. Why don't we find more? So thanks for watching, and don't forget to subscribe and hit the like button. Have a good day.